Imagine you want to send a secret message. You could try writing in invisible ink or using a code word. Hackers do something similar when they want to steal information from a computer network. They use a trick called DNS tunneling. DNS stands for Domain Name System. It's like the internet's phone book. When you type a website name into your browser, DNS helps your computer find its address. This process uses special requests called DNS queries. Hackers take advantage of this system. They hide stolen data inside these DNS queries. It's like sneaking a secret message inside an ordinary envelope. This sneaky method is called DNS tunneling. DNS tunneling is dangerous because it's hard to detect. The traffic looks like normal internet activity. This makes it easy for hackers to steal data without anyone noticing. Let's break down how hackers turn ordinary DNS queries into secret messages. It all starts with the data they want to steal. This could be anything from passwords to financial information. The first step is to break this data into small chunks. Think of it like cutting a cake into tiny bites. These data chunks are then hidden inside DNS queries. But where do these secret messages go? Hackers set up special DNS servers to receive them. These servers act like a secret mailbox for the stolen data. When the hacker server receives these specially crafted DNS queries, it extracts the hidden data. It's like opening the secret message inside the envelope. Most companies have firewalls to protect their networks. Think of a firewall as a security guard for your computer system. It checks all incoming and outgoing internet traffic for anything suspicious. Firewalls are good at blocking many types of attacks, but they often trust DNS traffic because it's essential for normal internet browsing. This is where DNS tunneling becomes dangerous. Since DNS tunneling hides data within seemingly innocent DNS queries, it can sneak past firewalls undetected. It's like having a secret password that lets you bypass security. This ability to evade traditional security measures makes DNS tunneling a powerful tool for hackers. Section 4, Secrets Out, Real-World Examples of DNS Tunneling Attacks. DNS tunneling is not just a theoretical threat. It's a real problem that has been used in many cyber attacks. One example is data exfiltration. Hackers can use DNS tunneling to steal sensitive information from a company's network. Imagine a scenario where hackers breach a company's network. They find a database full of customer credit card numbers. They can use DNS tunneling to secretly send this data to their server, bit by bit. Another use is command and control. Hackers can use DNS tunneling to send commands to malware hidden inside a network. They can also receive updates from the malware using the same technique. In one real-world case, hackers used DNS tunneling to control a botnet. A botnet is a network of infected computers that can be used to launch large-scale attacks. Section 5, Spotting the Smoke Signals, Detecting DNS Tunneling. Detecting DNS tunneling is like finding a needle in a haystack. The traffic often looks normal, but there are some telltale signs that security professionals look for. One red flag is unusual DNS queries. For example, if a domain name is very long or contains random characters, it could be a sign of DNS tunneling. Another clue is the volume of DNS traffic. If a single computer or device is sending out an unusually high number of DNS requests, it could be suspicious. Specialized tools and software can help analyze DNS traffic for these anomalies. These tools use advanced algorithms to identify patterns and detect suspicious activity. By carefully monitoring DNS traffic, security teams can spot the smoke signals of a DNS tunneling attack. Section 6, Building Stronger Walls, Preventing DNS Tunneling. While detecting DNS tunneling is important, prevention is always better than cure. There are several strategies that organizations can implement to mitigate this threat. One approach is to limit DNS traffic to legitimate servers. This can be done by configuring firewalls and other security devices to block DNS requests to unknown or suspicious domains. Another effective method is to use DNS security extensions, or DNSSEC. DNSSEC helps verify the authenticity of DNS data, making it harder for hackers to manipulate DNS responses. Organizations can also implement intrusion detection systems, or IDS, and security information and event management, or SIEM solutions. These tools can analyze network traffic for suspicious patterns and alert security teams to potential threats. By implementing a multi-layered security approach, organizations can significantly reduce the risk of DNS tunneling attacks.